In my first video on the law of sines, I derived the law of sines based upon a triangle. We called it an oblique triangle. Actually, we used an acute triangle just by the picture. By using a vertical line segment running from vertex B down to side B. Okay, and it was perpendicular to side B. And that's how we derived the formula for the law of sines. This diagram also gives us a formula for the area. You probably are familiar with the area of a triangle, general area of a triangle. That looks like the angle A. Actually, for area, we tend to use a script A. So the area is equal to 1/2 the base times the height. Okay, 1/2 base times the height. That's the general formula for the area of a triangle. And of course, that comes from the area formula for a rectangle. Right? Yeah, if you think about filling in a rectangle around this triangle here, then the area of that rectangle is the base times the height, right? Length times width, base times height in this case. But it's half of that because each of these sections, the triangle takes up half, right? This the green right triangle here and the blue right triangle are equal in size. This triangle and this triangle are equal in size. So the area of the big green right triangle is half of the area of the blue rectangle, right? So 1/2 base times height. That's where that formula comes from. Well, from that formula, we can expand. That to give us some formulas that are not based upon h, the height. The height is not often an easy thing to find. Sometimes all we can do is find the outer sides of the triangle. And so what we're going to do is we're going to set up formula just like we did with the law of sines by saying that the sine of A is equal to opposite over hypotenuse, so h over c for the right triangle on the left. Okay. Now, if I were to take this expression and solve for h, which we did before, we would multiply both sides by c, and we'd have h equals c times the sine of big A. Okay. Well, now, since that's equal to h, and h is in my area formula, I could make a substitution. Okay, so this h will become c sine A, and so the area is equal to 1/2 b times c times the sine of A. All right? We could, in theory, have run this perpendicular line from any of the vertices, any of the corners, and gotten a similar formula. I'll write the other two formulas that you could get if you run that a different way, but the derivation of it is the same, right? You set up the sine, solve for h, and then make a replacement. The other two formulas, area equals 1/2 AB sine C, and the area equals 1/2 AC times the sine of B. What you'll notice is that in each of these formulas, you're going to have the product of two of the sides and the sine of the third angle. Okay, so BC and A, AB and C, AC and B. So all three are included, all three letters, but you have the product of two of the sides with the sine of the included angle, essentially, right? AC, here's A, here's C, the included angle is B. BC and A. So here's side B, side C, angle A is the included angle. So all you need are two of the sides and the included angle, and you can find the area that way, okay? So we don't need necessarily to know the height, h. We just need to know the sides and the angles of the actual triangle itself. This formula can be useful. And so just as a quick example, if you had a triangle, let's go ahead and use this diagram. This time, let's just say that the area, or I'm sorry, the angle A is, let's say it's 55 degrees, and let's say side C is 22.6 feet, and side B, that's going to be a longer one, let's make it 46.3 feet. Okay, then we can use that information, just those three pieces of information there, to find the area. And if we didn't know two sides in the included angle, we may have to use the law of the law of sines to figure that out, right? So if I knew CA and A, I might need to use the law of sines to figure out what B is, all right? Or angle B and then side B or something. So we may have to use the law of sines, or we may have to use the angle sum formula to get what information we need. But eventually we need two sides in the included angle. So then I'm going to use this first formula and just plug stuff in as needed. So I have the area equals 1/2 my side B, which is 46.3, times side C, which is 22.6, times the sine of angle A, which is 55 degrees. And then we just go to the calculator, punch that in, and that should give us the area of this triangle. Let's go ahead and do that. Type in 1/2 times 46.3 times 22.6 times the sine of 55, and again make sure that you're in degree mode, and I get 428.6 roughly, if I round that off. And that will be in square feet, okay? Square feet because it's an area, so area is always in square units when the sides are in regular units, okay? Good, so that gives us an idea of how to work through that, but again, you could have any two sides, any combination of two sides with the included angle is all you need now to find the area.